All right, so get this. We're diving into a galaxy where a black hole's laser beam might be setting off star explosions.
Oh, wow.
Yeah, it sounds like straight up science fiction,
Yeah.
but it's happening 54 million light years away in a galaxy called M87.
M87.
M87. And you've given us a ton of articles to go through from NASA science journals, even some popular science websites.
Yeah, it's a really fascinating case. From what I've seen, the core of this is really kind of a mystery. Why are there so many more novae happening near this black hole's jet compared to the rest of the galaxy?
Okay, so let's unpack this a little bit. First off, can you remind us what a nova is? I know it's an exploding star, but there are so many ways a star can go out with a bang.
Right. Good point. Yeah. It's not a supernova, which is the complete, destruction of a star. A nova is specifically when a white dwarf star, and that's the dense leftover core after a sun-like star dies, pulls hydrogen from a nearby companion star, and this builds up until it ignites in a massive explosion on the
Like
surface.
a hydrogen bomb, but on a stellar scale.
Exactly. And the white dwarf actually survives this, so the process can actually repeat. Now, what's peculiar in M87 is that the Hubble telescope spotted twice as many novae close to this huge jet of plasma shooting out from the supermassive black hole at the galaxy center.
Hold on, plasma. Could you break that down for folks who might not be familiar with that term?
Sure, in simple terms, it's superheated matter, where the electrons have been stripped from the atoms. So think of it as gas, but so hot it's electrically charged. And this jet, it's spewing out from the black hole at nearly the speed of light, spanning a distance that's mind-boggling, 3,000 light years long.
Wow, that's an incredible amount of energy.
Yeah.
So how is this jet connected to these novae? It's not like it's pointing right at the stars and making them explode, right?
Right, it's more subtle than that, which is why it's such a puzzle. One theory is that the jet's energy is so intense it acts like a cosmic snowplow. It pushes hydrogen gas towards those white dwarf stars, which are already pulling hydrogen from their companions.
So it's like adding fuel to the fire, accelerating the process that leads to the nova explosion.
That's one possibility, but wouldn't the jet's energy also blow away the hydrogen, preventing it from reaching the white dwarf?
That's a good question. I hadn't thought about that.
Yeah.
Is there another explanation?
There are a few. Another idea is that the intense light pressure from the jet might be messing with how much hydrogen the companion star is feeding to the white dwarf. It's like a cosmic tug of war affecting the balance of the stellar relationship.
Interesting. But how can they actually test these theories? It's not like we can fly out to M87 and poke around.
No, unfortunately not. Astronomers rely on observations and computer models to test their theories, and they've already ruled out one idea: the jet directly heating up the companion star. The calculations just don't add up. But there's a lot more research to be done.
Okay, so we've got this mysterious connection between the black hole's jet and the increased rate of novae. But why should we here on Earth care about what's happening in a galaxy millions of light years away?
That's a fair question. I think there are a few reasons. First, understanding how black holes interact with their surroundings is crucial to understanding how galaxies evolve, and since we live in a galaxy that directly affects our cosmic neighborhood.
That makes sense.
Yeah.
It's all connected, even if it seems incredibly far away. Is there anything else?
On a more philosophical level, I think studying phenomena like this helps us grasp the sheer scale and power of the universe. It puts our own little world into perspective.
I can see that. It's both humbling and awe-inspiring at the same time. But tell me, is this kind of thing unique to M87, or are these black hole jets causing trouble elsewhere too?
This brings us to the Death Star analogy, which might be a little overused, but it helps to visualize what's going on.
Okay, let's hear it. I love a good pop culture reference.
Well, imagine the black hole, like the Death Star, shooting out those powerful jets. Now, these jets can actually change direction over millions of years, like a weapon sweeping across space. And wherever they point, they can disrupt star formation, pushing away the gas and dust that would normally clump together to make new stars.
So it's like a cosmic killjoy, preventing the birth of new stars.
In a way, yes. They've found evidence of these moving jets in other galaxies, suggesting it's not just a fluke in M87. This could have major implications for how galaxies evolve over time.
It's almost scary to think about the impact these jets can have, even from millions of light years away. But how do we even know this is happening? I mean, seeing something like that is pretty tough, right?
Absolutely. It takes incredible observational power. Ground-based telescopes can't see these novae in M87 because the black hole surroundings are just too bright. It's like trying to spot a firefly in the middle of Times Square.
Right.
Hubble was the key. It had to revisit M87 every 5 days for 9 months to get a clear picture.
Wow, talk about dedication.
It's amazing, isn't it?
Yeah.
And the visual evidence of more novae near the jet was so clear, it was almost undeniable. It really drives home how powerful a tool like Hubble is for unraveling the mysteries of the universe.
So we've gone from black hole jets to exploding stars to the evolution of entire galaxies. It's incredible how interconnected it all is. But before we get too lost in the vastness of space, let's dive a bit deeper into those Death Star black holes. How do they work? And what other havoc are they causing out there? This deep dive is just getting started.
These Death Star black holes, they really highlight how dynamic and even, I'd say, chaotic these cosmic giants can be. It's not just the raw power of those jets, but that they can shift direction over time. That's the part that throws a wrench into a lot of theories.
Yeah, you mentioned the shifting happens over millions of years, which sounds slow to us, but on a black hole timescale, that's pretty quick, right?
Exactly. And it suggests that something significant must be causing these shifts. One idea is that as matter falls into the black hole, it doesn't just disappear cleanly. It can actually increase the black hole's spin.
So the more it eats, the faster it spins.
And as it spins faster, those jets, they kind of get dragged along like a cosmic lighthouse beam sweeping across space. But there's another theory that focuses on the environment around the black hole rather than the black hole itself.
Okay, I'm intrigued. What's the other side of the story?
It could be that the gas and dust surrounding the black hole are also moving around, creating these pockets of empty space we talked about. If the jets are shooting into a moving target, their apparent direction would change, even if the jet itself stays fixed.
So it's less about the black hole changing its mind and more about its surroundings being in constant motion.
Precisely. But researchers have found evidence that points more towards the moving jet theory. They've looked at galaxies that have experienced mergers in the past, which would definitely cause a lot of gas to slosh around. And even in those galaxies, they've found evidence of moving jets.
Wow, that's pretty convincing.
Yeah.
So we're back to those powerful beams as the main disruptors. Earlier you mentioned that they can disrupt star formation. How does that actually work?
Yeah.
Is it like they're blowing the star-making ingredients away?
It's more about heat than wind in this case. Remember how incredibly hot those jets are? Well, stars need cool gas and dust to condense and form. The jets, they heat everything up so much, it's like trying to make ice in a furnace. It just won't happen.
So these black holes are kind of like cosmic killjoys keeping the galaxy from having too many baby stars.
In a way, yes. They can drastically reduce the rate of star formation. And if a jet suddenly changes direction, it can sweep across an area where stars were happily forming and disrupt entire systems, hence the Death Star nickname.
Yeah, I'm starting to see why that name stuck.
Yeah.
It's kind of a scary thought. Could one of these wandering jets ever threaten our own solar system?
That's a natural question to ask, but thankfully the chances of our solar system being hit by a black hole jet are incredibly slim. These events happen on such vast timescales and distances that it's not something we need to worry about.
Phew, that's a relief. But even if we're safe, it's still mind-boggling to think about these jets traveling for thousands of light years. Where are they even getting the energy for that?
It all comes back to the black hole itself. As matter falls in, it doesn't just vanish. It forms what's called an accretion disk, a swirling, superheated disk of material around the black hole.
Like a cosmic whirlpool, right?
A very energetic whirlpool.
Yeah.
The energy released from this swirling matter is what powers the jets. It's not fully understood, but we're talking about incredibly strong magnetic fields and the interplay of matter and energy under some of the most extreme conditions in the universe.
It sounds like the ultimate energy crisis, but on a cosmic scale, it makes me realize how much we still don't know about black holes. What about those novae in M87, though? Are they just a side effect of the black hole's activity, or do they tell us something more important of the galaxy as a whole?
That's an excellent question. It's not just a random spectacle. By studying those novae, astronomers are learning about how the black hole's activity affects the galaxy's environment. Remember, novae involve a white dwarf stealing hydrogen from a companion star. The rate at which that happens, and therefore how often novae occur, can be influenced by external factors.
So those little explosions are giving us big clues about the bigger picture.
Exactly. They act like a cosmic probe, allowing us to study conditions near the black hole and its effects on the entire galaxy. It's all connected. What happens at the center can ripple outward and influence events billions of miles away.
It's almost poetic, this interplay between the small and the large, the near and the far. We've talked a lot about the destructive side of these Death Star black holes. Could there be a constructive side to all this power?
That's a great question, and it leads us to a more nuanced view of black holes. They're not just cosmic vacuum cleaners, they can actually have a symbiotic relationship with their host galaxies.
Symbiotic, you mean they can actually benefit the galaxy?
In some cases, yes. Remember how we talked about jets disrupting star formation? Well, sometimes a little disruption can be a good thing.
Okay, I'm confused. How does that work?
Imagine a galaxy where star formation is going crazy. Stars are popping up everywhere, consuming all the available gas and dust. This can actually create a galactic traffic jam, leading to collisions and instability.
So it's like a party that's gotten a little too wild.
Exactly. And that's where the black hole comes in. By releasing those powerful jets, it heats up the surrounding gas, preventing it from collapsing and forming new stars. It's a way of slowing down star formation and bringing some order back to the galaxy.
So the black hole is like a cosmic bouncer, keeping the star-making under control.
A very energetic bouncer. And by regulating star formation, the black hole can actually help the galaxy live longer and evolve in a more stable way.
That's fascinating. So it's not all doom and gloom with black holes.
Huh?
But how do these jets actually shape the structure of a galaxy? It's not like they're sculpting things directly, right?
Not directly, but they can influence how matter is distributed throughout the galaxy. Imagine a jet plowing through gas and dust, creating shock waves and turbulence. This can trigger the formation of new stars in certain areas while preventing it in others.
It's like a cosmic landscaper shaping the galactic terrain.
A very powerful landscaper. They can even influence the formation of spiral arms in galaxies, contributing to those beautiful structures we see in images.
So these jets are both creators and destroyers. They can both nurture and disrupt. It's an incredible balancing act.
Yeah.
But how do we actually know all of this is happening? We can't exactly fly out to another galaxy and watch it all unfold.
That's the ingenuity of astronomy. We use a variety of telescopes, both on the ground and in space, to study black holes and their effects. By analyzing light radio waves and X-rays emitted from these objects, we can piece together a picture of what's happening even billions of light years away.
It's like a cosmic detective story, using clues from the universe to solve the mysteries of these black holes.
Exactly. And with each new observation, we get closer to understanding these fascinating objects and their role in the universe.
You mentioned earlier that astronomers found the oldest Death Star black hole in a galaxy that existed just 800 million years after the Big Bang. That's incredibly early in the universe's history. What does that tell us about how these supermassive black holes form?
That's a fantastic question, and it points to one of the biggest mysteries in astronomy. How did supermassive black holes get so big so early in the universe? The traditional theories suggest they grow gradually by pulling in gas and dust over billions of years, but this discovery challenges that idea.
It's like finding a fully green oak tree in a forest that's only a few years old. Something doesn't quite add up.
Exactly. It suggests that there might be other processes at play, ways for these black holes to bulk up much faster than we previously thought. Perhaps they form from the collapse of giant gas clouds, or maybe they merge with other black holes, creating a sort of cosmic snowball effect.
So it's a mystery with multiple suspects.
Precisely. And astronomers are actively investigating all these possibilities using observations and theoretical models to try and crack the code.
What are the implications of having these powerful black holes existing so early in the universe? Could they have played a role in shaping the cosmos as we know it today?
That's a great question, and it highlights how even the most distant objects can have profound effects on the universe as a whole. We know black holes can influence their host galaxies, and it's possible that those early black holes had an even greater impact on the evolution of the universe itself.
So they weren't just passive bystanders. They were actively shaping the cosmos around them.
That's the idea. For example, their powerful jets could have heated up the surrounding gas, preventing it from collapsing and forming the first stars and galaxies. That would have fundamentally altered the structure of the early universe.
It's like a cosmic domino effect, where the actions of these black holes triggered a cascade of events that shaped the universe we see today.
Exactly. And it's a reminder that even the most seemingly insignificant events can have far-reaching consequences on a cosmic scale.
Speaking of events, let's circle back to those novae near the jet in M87. Those observations from Hubble were crucial in revealing the black hole's influence. Can you tell me more about how those observations were actually made?
It was a remarkable feat of astronomical observation. Hubble had to overcome several challenges to capture those novae. Remember, we're talking about a galaxy that's 54 million light years away, and those novae are relatively faint compared to the intense light from the black hole and its surroundings.
I imagine it's like trying to spot a single firefly in the middle of a fireworks display.
A very distant fireworks display. To make things even tougher, Hubble had to revisit M87 every 5 days for 9 months to get enough data. This required incredible precision timing and a little bit of luck with clear skies.
It sounds like a logistical nightmare, but it obviously paid off in the end.
Absolutely. Hubble detected 94 novae within a specific region of M87, and their distribution clearly showed a concentration near the black hole's jet.
So it wasn't just random chance, there was a definite pattern that pointed to the jet's influence.
Exactly. The evidence was so clear that the researchers said statistics were almost unnecessary. It was a powerful visual confirmation of the jet's impact on its surroundings.
It's amazing to think that we can observe such subtle events happening in a galaxy millions of light years away. It speaks to the power of human ingenuity and our drive to understand the universe.
Absolutely. And it's not just about the technology, it's about the human element, the passion and dedication of the scientists who make these discoveries possible. Imagine spending years, even decades, studying a particular object or phenomenon, poring over data, refining your techniques, and constantly pushing the boundaries of what's possible.
It must be incredibly rewarding to finally see the fruits of your labor, to know that you've glimpsed something that no human has ever seen before.
It's an incredible feeling, a moment of pure exhilaration, a sense of awe and wonder at the vastness and complexity of the universe.
It's a reminder that we're part of something much larger than ourselves,
Yeah.
a story that's been unfolding for billions of years and will continue long after we're gone.
Precisely. And that realization can be both humbling and liberating. It can make our everyday problems seem smaller while also inspiring us to live more meaningful and purposeful lives. After all, we're made of the same stardust that forms those distant stars and galaxies. We're connected to the cosmos in ways we're only just beginning to understand.
Speaking of connections, we've talked a lot about the science behind these discoveries, but I want to touch on the human side of things.
Oh.
What's it like for astronomers to make these groundbreaking observations? What kind of emotions do they experience when they realize they've stumbled upon something truly remarkable?
All right, so we've explored this galaxy with a supermassive black hole shooting out jets of plasma, learned about Death Star, black holes wreaking havoc, and witnessed the drama of these exploding stars.
Yeah.
It's amazing how much we've uncovered about these cosmic giants just from the research you provided.
Yeah, it really is a testament to the power of scientific inquiry. And we've only just scratched the surface.
Black holes challenge our understanding of the universe in such profound ways, and the more we learn, the more we realize how much more there is to discover.
It's definitely been a mind-expanding experience, but let's bring it back down to Earth for a second. What does all this knowledge about black holes actually mean for us here on our little blue planet?
That's a question I think a lot of people ask. On a practical level, studying black holes might seem like a purely intellectual pursuit.
Right.
But the technologies developed to observe these distant objects often have applications here on Earth. Think about the advancements in imaging data processing, even materials science that stem from astronomy research.
Right, I see your point. It's like how studying these extreme environments around black holes can lead to breakthroughs in understanding matter and energy, which could have all sorts of benefits here.
Exactly. But beyond the practical applications, there's a deeper philosophical impact. Contemplating the vastness of the universe, the power of black holes, and this intricate dance of stars and galaxies, it gives us perspective, a sense of awe and wonder that transcends our everyday lives.
I can definitely relate to that. It's a reminder that we're part of something so much bigger than ourselves. A story that's been unfolding for billions of years and will continue long after we're gone.
It can be both humbling and inspiring at the same time. It can make our problems seem smaller and encourage us to live more meaningful lives. After all, we're made of the same stardust that forms those distant stars and galaxies.
It's incredible to think that we are literally stardust. It makes the universe feel a lot less abstract and more tangible.
That connection is what makes astronomy so captivating. It's not just about distant objects, it's about understanding our place in the grand scheme of things.
Speaking of the grand scheme, we know that novae occur daily in M87. But considering there are billions of galaxies out there, how many of these stellar explosions are happening across the universe right now?
It's truly mind-boggling to consider. With trillions of stars in the observable universe and a certain percentage experiencing novae during their lifespans, countless stellar explosions are likely happening at this very moment. It's a constant cosmic fireworks display that we can't even see.
If only we had a telescope powerful enough to witness all that cosmic energy, it would be an incredible sight. As we wrap up this deep dive, what's the one thing you hope our listener takes away from all of this?
I hope they grasp that the universe is a dynamic, ever-evolving place full of mysteries and wonder. Black holes, with their incredible power, are just one piece of this grand cosmic puzzle. And as we continue exploring, we're bound to make even more astounding discoveries that challenge our understanding and expand our horizons.
Well said. We've gone from a black hole's jet to exploding stars to pondering the vastness of galaxies. If our listener is as fascinated by all this as I am, they should definitely check out the amazing sources we've discussed. And remember, the universe is full of mysteries waiting to be unraveled.
Happy exploring!